Forward Optimizer video, in particular the output that the Power Walk Forward Optimizer generated in the previous run that I showed you using the repeated median and the Power Walk Forward Optimizer strategy. Here we see one of the files that the Power Walk Forward Optimizer generated. Basically, this file was when I double-clicked this first file right here. I moved all the files from the temp directory to my Walk Forward data directory, and I named the particular folder the same as the stub that I named in the input to the Power Walk Forward Optimizer. The Power Walk Forward Optimizer generated all these files. There's some 566 of them, as you can see. The first file, I've sorted these with respect to alphabetical order. So the first file is also named with the stub plus a date. That date is the end of the out-of-sample date, in this particular case, 12/7/18, the last out-of-sample date that we had. And its total out-of-sample date is 7 days, so from the close of 11:30 to the close of 12:07. Each file has basically its own out-of-sample date because it's shifting forward in time. Well, here you see it shifting backward in time. The next out-of-sample file, because I sorted this with respect to alphabetical order, ended on 11:30. The other one ended on 11:23, and the in-sample data are 30 days before that, etc., until we reach the end of the 566 files. Now we'll look at what's in each of these files. Here I put it into Excel. As you can see, the first line is the start of the in-sample date, which in this case is 11/1/2018, ending on 11/30/2018. And then the out-of-sample dates would be from the close of 11/30/2018 to the close of 12/07/18. That's 7 days hence. Each one of these rows contains a set of inputs. The reason why they're not in particular order is because they're run on a machine that has 8 cores and can run each one of these independently of itself. So when one gets done, it prints it. So if it doesn't get done, so if the earlier one, like row number 10, didn't get done as fast as the other rows, then it would be printed in the order that it was done. Being that they're in no order is no consequence to the Walk Forward Metric Explorer or Walk Forward Input Explorer, because they both automatically sort them when the data is inputted. Next to the input variables are the metrics that I use. The metrics, there's some 30 of them, or 32, and they extend all the way to column AM. Column AM starts the out-of-sample returns. In other words, for this set of inputs during the out-of-sample period, these were the returns that it generated. The out-of-sample net profit, this is before commissions and slippage. I don't usually add commissions and slippage because the Walk Forward Metric Explorer and Walk Forward Input Explorer both allow you to enter what your commissions and slippage are. And the reason why I don't enter it here is if in the future it changes, then you can make a run with the different commissions. Whereas if you had it included here, then you could never change. Nevertheless, the next column was the out-of-sample number of trades. The next column is the out-of-sample winning net profits, the out-of-sample winning number of trades, the largest losing trade, and the out-of-sample drawdown. In other words, these are all based on 63 out-of-sample trades. We will next examine what these various metric columns are. So I'm going to flip over to basically the manual, and we'll take a look at what the various columns mean. Columns A through F were the input parameters. If you had more input parameters, then they would go from A to whatever number that you had, and then metrics would start appearing exactly after whatever the end of the inputs are. M trade is the median of all trades in the in sample section. In other words, all trades for any given set of inputs, we found the median. We do that instead of the average because sometimes there's some outliers that can distort the average. So I like the median, which gives a truer picture of what the average trade is. Total net profits, TNP is total net profits in the in-sample section. NT is the number of trades in the in-sample section. Percent P is the percent of those trades that were profitable. PF is the in-sample profit factor. STD is the standard deviation of all the trades. T is the student's T statistic used to determine the probability that the average profit was greater than 0. So the higher T, the greater the probability. L bar is the median of the losing bar trades. Each losing trade has a number of bars, and if we take all the trades and take the median of those losing bars, that would be median losing bars. Total losing bars in all losing trades, we just add up all the losing bars. The median winning bars in winning bar trades, and then the total winning bars in all winning trades. M winning bars divided by M losing bars is just a ratio, and total winning bars divided by total losing bars is another ratio. Here is a new metric. When you have a trade, you have a maximum trade up or trade run up, and then you have a final profit. So each trade has one of these, has a number. And what we do is take the median of this number because it kind of gives an indication how your trades end up on each trade. Also, we have a median profit minus rundown. The final profit minus the maximum trade rundown. We want the final profit to be as high as possible over the range between the maximum trade run up and the maximum trade rundown. So this would be the median of this difference. WR is the maximum consecutive winning trades in a row. LR is the maximum consecutive losing trades in a row. M winning trades. This is the median of all the winning trades, and this is the median of all the losing trades. And this is the ratio of the median of winning trades to losing trades. DD is the drawdown in the in-sample section. LLT is the largest losing trade in the in-sample section. Equity trend is the slope. Each set of inputs and number of trades generates an equity graph. Equity trend is the trend of the equity trend line. R squared is the R squared coefficient, the correlation coefficient of the trend line and the equity line. M deviation is the median of the absolute deviations of the equity from a straight line curve fit to the equity. Then I fit a second order polynomial to the equity curve. EQB1, EQ2, which means second order polynomial, B1 coefficient. Equity 2V is the velocity at the end of a second order polynomial fit to the equity curve, and EQ2A is the acceleration. K tau is a non-parametric correlation coefficient. What it does is basically measure how close a line fits to the equity curve. It could be a curved line, it could be a straight line. Modified K ratio is just the equity trend divided by the median deviation. E minus 3 is the end equity minus equity 3 trades to go. Shows how fast the equity curve is moving in the last moments, in the last 3 out of sample dates. Equity trend is the projected equity 10 trades in the future using the second order polynomial line. And of course, then the out of sample section, which I explained above, has its parameters as well. In the previous section, I failed to note one extra variable. If the out-of-sample period is set equal to 0, then Power Walk Forward Optimizer will only run the latest in-sample days, and will create a file with just the in-sample data performance results and no out-of-sample results. This is done so that you can use the Power Walk-Forward Optimizer to generate the output performance results of the latest test periods to choose the input parameters to use for trading in a future period. Basically, what you want to do is, for instance, the Walk Forward Metric Explorer video explains this, but what you want to do is, like in the Walk Forward Metric Explorer, it has a metric filter. And so what it does is it looks at a number of metrics in the in-sample period and determines what set of input values it's going to use on the out-of-sample data. And so that's what this is for. So if you're running real time and it's Friday or Saturday, and you would run this, the Power Walk Forward Optimizer with a zero out-of-sample period set to 0, then you would run another XL8 file where you will plug in, for instance, the Walk Forward Metric Explorer metric numbers, and it will pop up with the input values you should use on your strategy in the next week. This is fully explained in the Walk Forward Metric Explorer video. Also, same happens with the Walk Forward input file. This concludes the videos on the Power Walk Forward Optimizer and what it does. Feel free to email me at support@myersanalytics.com or call my business line anytime after noon on regular business days. The next video will show how the Walk Forward Metric Explorer uses the Power Walk Forward Optimizer, and I encourage you to see that video.